Dear friends, in this video lecture, we are going to explain the concept of excess pressure across the free surface of a liquid and another excess pressure inside the liquid drop. We will do this one by one. Free surface is the surface of liquid which is at the interface of liquid and the air. For that, let us consider we got a container. This container is partially filled with a liquid. Now, on either side of free surface of liquid, let us consider A is the point which is in air above the free surface of a liquid. B is the point which is below the free surface of a liquid. A and B are the 2 points on either side of free surface of a liquid and they are very close to each other. Therefore, the distance measured from the bottom of the liquid level from bottom to B and bottom to A is negligibly small. The level difference between A and B is very small. Thereafter, we will consider a point O. O is the point of contact of liquid surface. O is point on the surface which is in contact with liquid as well as with air. At point O, a force of surface tension act tangential to the liquid surface from all sides. Therefore, the force of surface tension acting at point O acts from all sides and cancels each other. Therefore, the force of surface tension is not able to produce any excess of pressure, or rather, as the force of surface tension is horizontal, it does not have any vertical component acting on the surface. There is no any net vertical force on the surface. With absence of net vertical force on the surface, there is no excess of pressure and therefore the pressure on both A is same as pressure on B and hence there is no pressure difference on either side of horizontal liquid surface. Instead of that, if we think of a liquid surface which is concave in shape, this is the liquid surface which is concave up. This is liquid surface concave up. You know when the liquid surface is concave up, When angle of contact is acute, the liquid surface is concave upward. For this liquid surface also, we will consider 2 points. One is A, just above the concave side, and B is just below the concave side. O is the point of contact of the liquid surface. Now, the force of surface tension at O is tangent drawn at O. Now, the tangents for the point O are as shown in figure. The resultant of these two tangents will be vertically upward. Rather, we will explain in different way. This force of surface tension, which is represented by T, is resolved into two components. This is the horizontal component of force of surface tension, and horizontal component of force of surface tension cancels each other because they are on the same line and in opposite direction, but the vertical component of force of surface tension add with each other. Therefore, resultant of force acting on the concave side is vertically upward. This is the resultant. And the atmospheric pressure in this case is acting downward. Now, in this is atmospheric pressure. Let it is represented by P0. The resultant is upward, atmospheric pressure is downward. In order to attain an equilibrium, the excess of pressure acts on the concave side. Therefore, the excess of pressure here acts on the concave side. Therefore, pressure on the concave side is greater than that on the convex side. Pressure on A, that is pressure on the concave side of the liquid surface, is more than that of the pressure on the other side or convex side of the liquid surface. In a similar manner, if you think of a liquid which do not weight the solid, the liquid surface is convex upward. Here is the point O, point of contact. The force of surface tension is along the tangent. This is the force of surface tension. You can resolve this force of surface into two perpendicular components. This is the horizontal component of force of surface tension, and this is the vertical component of force of surface tension. All the vertical components of force of surface tension acts with each other, and a resultant force acts in a vertically downward direction. Obviously, there is a force of atmospheric pressure acting in a downward direction. The resultant of force of surface tension is also in a downward direction. In order to attain an equilibrium, the excess of pressure act in a upward direction. Therefore, if I think of point A on the convex side, convex up, and B on the other side of convex portion, or it is on the concave side, therefore here you will get that pressure on B is greater than pressure on A, or rather pressure on A is less than pressure on B. In short, with this explanation, we will say that for horizontal liquid surface, there is no pressure difference. Pressure on either side of the horizontal liquid surface will be the same. For concave liquid surface, the pressure on the concave side is more. For convex liquid surface, pressure on the convex side is less. This is one and the same. The pressure on the concave side of the liquid surface is more than the pressure on the concave side of the liquid surface.